Hello grade 11s and welcome back to another video. In this video we're going to take a look at question number 2. This is a question on Newton's law of universal gravitation, but if you look carefully and try to analyze the question very well before working through it with me, you may notice a question on Newton's third law. So remember to pause the video, try it yourself, see if my hints help you, and when you're done, work through this video with me or watch the video and work through the question with me to see if you're on the right track. So this question says, the Earth and Jupiter are positioned in the universe such that they are 5,88 times 10 to the power of 9 meters apart. The radius and mass of Jupiter is 6,99 times 10 to the power of 7 meters and 1,898 times 10 to the power of 27 kilograms respectively. Now, if this statement confuses you, when they use the term respectively, they mean the radius is the first number because it was mentioned first. The mass is the second number because it was mentioned second, okay? But you should also be able to tell because radius is distance measured in meters and mass is measured in kilograms. Fortunately, over here we have a nice diagram to show us where the distance is. And question 2.1 says, state Newton's universal law of gravitation in words. Newton's law of universal gravitation says that each particle in the universe attracts every other particle. Here we're referring to particles because particles have mass, with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Now, as normal, I do recommend that you try to find these definitions or statements or laws in the actual formulae. Let's take a look at this formula that we use for Newton's law of universal gravitation. We have at the left-hand side, or on the left-hand side, the force, the gravitational force. We see at the top the mass of the first object multiplied by the mass of the second object. Therefore, we say, as the product, remember product means to multiply. M1 times M2 is the product of the masses. So as the product of the masses increases, the force, the gravitational force between the masses is going to increase. And that is why we say they are directly proportional, or the force is directly proportional to the product of their masses. We see at the bottom of this formula the distance between the centers, and it is squared. Therefore, as the square of the distance between their centers increases, since it is in the denominator, we know that as this number increases, the force is going to decrease. We therefore say it is inversely proportional to the square of the distance between their centers. And this centers is very important because that is going to help us with the next part of this problem, the second question. So this statement is going to get you 2 marks. 1 mark is normally awarded for the first part where you mention the product of their masses, and 1 mark for the second part. But depending on the examiner, it may be 2 marks or nothing. So be sure to learn your definitions very well, or your statements and laws very well. Question 2.2 says, calculate the magnitude of the gravitational force that Jupiter exerts on Earth. So to calculate that, we're going to say the gravitational force is equal to the gravitational constant multiplied by m1 multiplied by m2 divided by r squared, where m1 and m2 is the mass of Jupiter and the mass of Earth. R is the distance between their centers. Now notice that this is not the distance between their centers, so we're going to have to perform a calculation. Here's the center of Jupiter. How are we going to get this distance? Well, that distance is the radius that was provided to us over here. Earth also has a radius, and there's its center. So how are we going to get that radius? Well, remember I spoke to you about your table of constants. In this table of constants, you're going to find the radius of Earth, RE, given as 6,38 times 10 to the power of 6 meters. That is 6,38 times 10 to the power of, I think we said 6. Yes, 6 meters. So that information is actually provided to us, and therefore we can say that the radius, we're going to write this down in our calculation, is equal to 6,99 times 10 to the power of 7 plus the distance between them, 5,88 times 10 to the power of 9, plus the radius of Earth, 6,38 times 10 to the power of 6. And when we plug this into our calculator, we get an answer of 595628000 meters. Okay, make sure that you copy down these long answers very carefully. If you're very lucky, you may have been given this value in scientific notation, but this is what my calculator provided. Now we also need the mass of the Earth. We have the mass of Jupiter. There is the mass of Jupiter over there. The mass of the Earth we can also get from our table of constants. So if we go towards the bottom of the table of constants, we see mass of Earth is ME 5,98 times 10 to the power of 24. That is 5,98 times 10 to the power of 24 kilograms. So now we can plug all of these values into our formula. G, which is the gravitational constant, is given in this table of constants as well, so you do not need to learn it off by heart. It is 6,67 times 10 to the power of negative 11. That is 6,67 times 10 to the power of negative 11. Let's make sure that I copy down that correctly. Yes, I did. Now we must plug in the masses. We're going to multiply by the mass of Earth, 5,98 times 10 to the power of 24. And then we're going to multiply this by the mass of Jupiter. The order doesn't matter because we're multiplying. The mass of Jupiter is 1,898 times 10 to the power of 27. Okay, there is the mass substituted in. Now we're going to divide both sides. Sorry, not both sides. We're going to divide all of this by the distance between them. Now remember, the distance is that very long number, which is given as follows. It is 595628000. And we must not forget to square this. I forget, my learners forget. It is so easy to forget the square in this formula and when you're calculating the force or the electric field, the electrostatic force or the electric field. We often forget that square. So please always go back and check and make sure that you did not leave out that square. So now we plug all of this into our calculators very, very carefully. When I plug this into my calculator, I get a final answer, which I hope is correct. And that final answer is equal to 2,13 times 10 to the power of 22 newtons. This is a force. It may be a very, very big force, but it is measured in newtons. This question is out of 4 marks. You're going to get 1 mark for your formula, 1 mark for your substitution at the top, 1 mark for your substitution at the bottom, and 1 mark for your final answer. You only needed to calculate the magnitude of the force, so that is your answer. No direction required. We now move on to question 2.3, which says, what will the magnitude of the gravitational force that Earth exerts on Jupiter be? So we just calculated the force that Jupiter exerts on Earth. So Jupiter is pulling Earth towards itself. The question is, what will the force be that Earth exerts on Jupiter in that direction? Because Earth is also going to pull Jupiter. The correct answer is that it's going to be exactly the same in magnitude. It's going to be 2,13 times 10 to the power of 22 newtons. It does not matter that Jupiter is bigger than the Earth. It does not matter that the Earth is smaller than Jupiter. According to Newton's third law, This force is equal to that force. They are equal to each other in magnitude but opposite in direction. Newton's third law says if object A exerts a force on object B will simultaneously exert an equal but opposite force on object A. And that is the case over here for 1 mark. Please ensure that you wrote down the correct unit. Now question 2.4 says, calculate the magnitude of the acceleration due to gravity on Jupiter. Now you can go and have a look at your formula sheet, and you can look, and you're going to see that there's no formula here that's going to help you to find G. But there is a way of finding that formula that you're very familiar with. This is actually Fg, and this is Fg as well. So we have G m1 m2 divided by r squared is equal to m1g. We can cancel these m's, and we have that G is equal to Gm2 divided by r squared. In other words, if we would like to calculate the gravitational acceleration due to Jupiter, we can simply say G is equal to the gravitational constant multiplied by the mass of Jupiter divided by r squared. So G is a constant. We know that that constant is given to us in our table of constants as 6,67 times 10 to the power of negative 11. R is going to be the radius of Jupiter, which was given to us in the question as 6,99 times 10 to the power of 7 meters. And once again, we must not forget to square this value. So we square it, and in the end, plugging it into our calculators, we find out that the final answer is, oops, we can't find the final answer yet because I forgot the mass of Jupiter. So the mass of Jupiter was given to us in the question as well, 1,898. So we times by 1,898 times 10 to the power of 27. So we plug all of this into our calculators, and if I have performed this calculation correctly, I find that the gravitational acceleration is 25,91 meters per second squared. And that is the answer to question 2.4 out of 3 marks. You're going to get 1 mark for your substitution at the top, 1 mark for your substitution at the bottom, and 1 mark for your final answer. Of course, instead of giving both marks in the substitution, we may give a mark for the formula instead. But that is the answer to question 2.4. So now we go on to question 2.5, which says, you are involved in the design of a shuttle to transport people to the surface of Jupiter. The shuttle has a mass of 4,000 kilograms on Earth. Calculate the magnitude of the weight of the shuttle on the surface of Jupiter. So we know weight, Fg, is equal to mg. We are calculating the weight on Jupiter where the gravitational acceleration is 25,91. This value, the mass, is constant no matter where we are. So we plug in the mass of 4,000. We're going to multiply it by 25,91, or our answer to question 2.4. And when we say 4,000 times 25.91, we obtain a final answer equal to 103640 newtons. That is the magnitude of the weight of the shuttle on the surface of Jupiter for 3 marks. You're going to get 1 mark for your formula, 1 mark for your substitution, and 1 mark for your final answer. Some of you may have instead made use of this formula and obtained exactly the same answer. In that case, you would substitute in the mass of the shuttle here, the mass of Jupiter there, and the radius of Jupiter in the place of r. And grade 11s, this brings us to the end of this problem. Thank you so much for joining me. In the next video, we're going to take a look at an electrostatics question. So please be sure to join me there.